The law of sines is used to solve oblique, which means non-right triangles, okay? Triangles when given, that says triangles, when given an angle, a side and an angle, or an angle, an angle, and a side, or a side, side, and an angle. But with a side, side, and angle, you must know it's an acute. Must know it's an acute triangle, meaning meaning there's no obtuse angles. It's acute. You can use law of sines with side, side, angle if it's not acute, but that's called the ambiguous case, which you don't deal with until you get to a higher course. Okay? So, do you want to know where law of sines comes from?
Oh, yes.
I'm going to show you anyway, even if you don't know. Okay? So even if you don't care. Because sometimes some people like to know. Okay? So if I have any old triangle, let's say this is a non-right triangle. You don't have to draw this picture. I'm just kind of showing you where it comes from. Okay? And this is a, here's the height of this triangle. And I call this side A, this side B, and this are angle A, angle B, and angle C. And opposite angle A is little a, and opposite angle B is little b, and opposite side C is little c. So I know that the sine of angle A, okay, is equal to what over what? Looking at this right triangle right here. What's it equal to? Opposite over hypotenuse. What's opposite over hypotenuse in this little triangle? H over B. Very good. Okay? H over B. The sine of angle B is equal to, you do not have to write this down. I'm just trying to show you where the law of sine comes.
H over E.
H, not H over C.
H over A.
H over A, right? Because this is the hypotenuse of this triangle. And then what you do is you solve both of these equations for H. So if I multiply both sides by B in this problem, I get B sine A equals H. And over here I get A sine B equals H. And since H has to equal itself, I can do substitution and I can put this over here. Okay? And then what I get is B sine A is equal to A sine B. And then what they do is they divide both sides of this equation by both side A and side B. And what happens to my B's in this case? What happens to my B's? Those cancel out. And what happens to my A's in this case? They cancel out. And what's left over is called the law of sines. Okay? Sine of A over A is equal to the sine of B over B. And if I flip this triangle around and I did it again, which I'm not going to do, okay? And that's equal to the sine of C over C. In other words, the sine of an angle over its opposite side has the same ratio as the sine of another angle in the same triangle over its opposite side, which is equal to the sine of C over its opposite side. Get it? That's called the law of sines. Okay? So let's do a problem involving the law of sines. You ready? Okay, here we go. Anyone want me to pause for station identification, guys? We're okay? Okay. Okay, so moving on. Here's a triangle. New page. New page. Here we go. Ooh, you guys are being a very good audience today.
Thank you. Thank you.
Okay, you're welcome. All right. So, it didn't make a triangle. What happened? Oh, I used the wrong tool. I got to use this tool.
They added the orange shirt kid.
Hey, young man, I'm not going to mention any names in the video because you're going to be posted on YouTube pretty soon.
Shout out Gary Wendorf. Is this being
H,
recorded?
A, yeah, it's being recorded.
No.
Wait, do you
And,
have to sign something?
No, not if I don't say your name.
So you can use audio but no visuals? Or you
Yeah, I think so, because no one knows who you are, okay? Okay, so find A and B, okay? So this is how you use all signs. So notice that this is a not a right triangle. With SOHCAHTOA, where you use all three trig functions, you have to have a right triangle. This one, you don't have a right triangle, okay? So so who could tell me what so notice that I said for love signs you could use either angle side angle, right? Or AAS, remember AAS? Or SSA, SSA. Which one of those three things do I have here? An angle, and a side. So that tells me, oh, I'm okay to use love signs, okay? So anyone want to guess what my first step might be? There's an easy angle you could find. What angle could I find? You could find angle A, okay, which probably you want to do by subtracting from 180, right? And everyone knows that that's a 30 with a squiggly in the middle, right? So that angle is 30 degrees. Hey, no singing, okay? Now, you better be quiet or I'm gonna start singing, okay? And you're gonna have to run, okay? What? Yeah, my family likes me to sing. They're always asking me to sing that song. The Far, Far Away.
Can you sing it?
They say, can you sing Far, Far Away?
It's okay.
Okay, so you get it far, far away from here, you know. So in any case, so you can set up the loud signs to say that the sine of 30 degrees, right, is to A as the sine of 50 is to what?
Is too big or small?
What's across the street from 50? 8. Okay? So an 8 goes over there. Get it? So it's just the sine of this is to its opposite side as the sine of this is to its opposite side. What I can't do is say sine of 100 is to B as sine of 30 is to A, because then I would have two variables, right? So if you know three things, you're going to find the fourth things, right? And so I set it up that way. And then I need to solve this equation for A. How do I do that? Cross multiply. Very good. So your first step is to multiply this like this, cross multiply. And I get 8 sine 30 degrees equals A sine 50 degrees. How could I get A by itself?
Divide.
Divide both sides by?
8.
Not 8. I want to get A by itself.
It's 30. It's not 30.
Not sine of 30.
Sine.
Sine of what? 50. By the way, you cannot just divide away signs, because sine is like a function. It's like square root or multiplying. So you can't just cross out signs, but you can cross out a sine of 50 on this side and a sine of 50. Whoops, sine of 50 on this side, right? And then I cross those out, okay? And I get A is equal to this. It's better to solve the whole thing in one chunk like that than it is to like find out what the sine of 50 is and divide by sine of 50 or sine. You want to plug it all in one chunk into your calculator. So now I'm going to pause for a second because I got to get my calculator, guys. Okay, unpause. And so now I'm going to just plug this whole chunk into my calculator. So I'm going to go 8 sine 30 divided by sine, whoops, be careful. You got to close that parentheses. See, I made a mistake that you guys will probably do. Divided by sine of 50. Sine of 50. What happened?
You messed up.
divided by sine of 50, and I hit enter after I close that parentheses, and I get 5.22. So side A is about, don't mess up on me, we're having a very good lesson here, 5.22, okay? How would I find side, so now I know A, how do I find B?
You do.
A plus B.
Give me a, who could give me an equation to solve for B?
equals C.
You cannot,
Not a right triangle.
it's,
Yeah, it's not
so,
90 degrees.
okay, so do not do Pythagorean theorem because it's not a right triangle, right? You can only use Pythagorean theorem. So you have to use law of sines again. Who can give me the equation to set it up? Go ahead, Bray. Sine of 100. That will work, but better to use 50 and 8 because these are more exact. So this 5.22 is rounded off, so it's better to use the exact one. That'll work, but your answer will be a little bit off, okay? So what Bray said is right. Basically, you use sine of 50, right? Use the one that's already given to you. Sine of 50 is to 8. Sorry, I'm moving. Sine of 50 is to 8. As sine of 100, sine of 100 is to B. Go ahead, find it. First one, the right answer gets a valuable point. Pause. So, ladies at home in the viewing audience, ladies and men, and everyone, okay, the answer is 10.28. That is correct. Okay? Any questions on that? So now we've solved the triangle. Yes, Bray?
Would you always use sine?
Always use sine, it's law of sines. Yes, tomorrow we're going to use law of cosines. Okay? Law of cosines, which is different situations. Now the other thing is, what was I going to say? If I got an answer like over here, say I said that this answer was like 4, how would I know that's wrong? How would I know 4 is not a right answer? How would I know I did
Because it's
something?
the big sign and
Very
it's
good.
smaller
Okay.
than 5.
Right, because what Rod said is absolutely, what this person in the front row just said is that's got to be the biggest side. Uh-oh, touch on. Oh no, I was doing so well. That's got to be the biggest side. So if I got 4 over there, I know that's got to be wrong, right? So should kind of use some common sense. Okay, so the next thing we're going to do, folks, is we're going to make another triangle. And now we're going to find one that needs, where you need to find an angle. Okay?
No.
Yeah. Seriously. Okay? So this is going to be an acute triangle. And I'm going to put like a side over here. We're going to call this 12. We're going to call this 11. And we're going to call this 73 degrees. Okay? And I'm going to call this just, can I move? Yes, I can move. Okay? And I'm going to say find, let's call this C again. Now the letters don't always have to be A, B, and C, but you can call them X, Y, and Z and stuff like that. It's just that this goes to, so which situation do I have here? Angle, side angle, or side angle?
Side, angle.
Side and a side and angle. So again, I can use law of sines, but I have to know that it's an acute triangle, meaning all angles are less than 90 degrees. Otherwise, you run into ambiguous case, which you'll learn about next year. Okay, so in this case, let's try to find angle A. Okay, so find A and C. Find A and angle C. Angle A, and angle C. So I would say that the sine of A, which I don't know, is to what? 12, as the sine of 73 is to 11. you can't say that the sine of c is to c because then you'd have two variables, right? So we'll worry about c later. Now what? Don't totally cross multiply, just you want to get sine of a by itself. So I'm going to multiply both sides by 12. See? 12? See what I did? Because that makes that go away. And I get sine of a is equal to this. Yes? So I'm going to plug, so I know that sine of a is equal to about, okay, I'm going to plug this chunk into my calculator, okay? I'm going to do it right here. So sine 73, sine of 73, close your parentheses. If you have an older calculator, someone, I think like Jacqueline has that kind, you might have to go 73 and then sine. Some of them work kind of backwards. Depending, if you do have an older version of a calculator, you have to do 73 sine. I'm not sure on that one, but well, if you run into problems, that's probably why you're getting the wrong answer. Sine 73 times 12 divided by 11 equals, I did something wrong. What happened? Oh, divide.
I think.
Oh, I missed. Sine of 73 is to 11 as sine of a is to 12. I multiply both sides by 12 divided by 11. What's wrong? Is something wrong? Does that not work? Sine of
12 divided by 11.
Sine of 73. Oh! Is to 11 as sine of a is to 12. That should work. What did I do wrong? Sine of 73 times 12. Let's do that again. Sine, let me see. Sine of 73.
Yeah, because the sine of 73 times 12 is 11.
Yeah, you gotta do the 12
Times 12 Oh, so that's an interesting problem. What I just did is I made a triangle that doesn't work. Okay, because when you get to trigonometry, you'll find out that this side has to be smaller than this side, otherwise it won't make a triangle. Okay, but so what I'm going to do, I'm just going to adjust it. Sorry about that. Oh, now we're all messed up for our viewing audience. It's okay. I'm going to make this side. I got to make this side smaller. I'm going to make this or bigger, right? Bigger. So I'm going to make it 13. Okay, because that's what happens when you make up things by yourself. So that's a good. Some triangles don't work. So now I'm going to say that the sine of 73 is to 13, okay, as the sine of a is to 12, okay? Because in that last case, what would have happened if I had a 73-degree angle right here, just to show you why that didn't work? If this side is 12 and this side is 11, it's not going to reach the other side, okay? That's what happened in that triangle. That's called, there is no triangle. When you get to pre-calc, you'll learn about that. But right now, we're just going to do that. Sine of a is equal to 12 sine 73 divided by 13. Okay? And I'm going to do that on my calculator. Okay? So I get 12 sine 73 divided by 13, and if I do that, I get a decimal answer, 0.88. What do I do with that decimal answer? What do I do with that decimal answer? If I know that the sine of a is equal to 0.8, approximately 0.827, how do I find out what the angle is? Then I do this second. That's where I want to find the angle, so I use my inverse sign. So I'm going to go second sine, second answer. Okay, so what that does, it takes this number and plugs it in there, and it finds the angle has a sine of 0.8827, and I get 61.97 degrees. Okay, so angle A is 61.97. Do I have to do that again to find angle C? Do I have to do that? Please tell me I don't have to do that again. How else could I find angle C? Just subtract these two angles from 180, right? Easier, right? You don't want to go through that process again, right? So this angle C is equal to 180 minus 61.97 and 73, right? So if I do that, you can do that. 180 minus 61.97 minus 73 equals 45. So this angle up here is about 45.03.
It would actually be 67.9.
Oh yeah, Mia's right, 67.98.
61.
Okay, round off to the nearest tenth. Okay? Whatever you do, don't do this. That's not right. Don't do this. Is this true? Sine of x over n equals 6?
What?
Sure.
Why? Because look, all you have to do for this one is cancel out the ends.
And now it's just 6 equals 9. I mean,
Okay.
6 equals 6.
6 equals 6. Right? You just cross out the ends. Okay. Hey, let's pause for station identification. Here we go, guys. We're recording. We're live. We're live. So there is another formula for oblique triangles. Am I recording? It's ticking, right? It's ticking. Okay. So there's this area formula which comes out of the law of sines. It's kind of like for oblique triangles. So area of an oblique triangle, okay, it comes out of combining the area formula for any triangle of an oblique triangle. If I have two A, B, C, right, little a, little b, little c, okay? It's sine, so, oh, come on. So, area equals, hold on, A, come on, A, B, sine C divided by 2, which is equal to BC sine A divided by 2, which is equal, I'll show you what I mean, AC sine B divided by 2. This is a very convenient formula. What it does, whoops, sorry, okay. What it does, okay, is it eliminates the need to find the height of that triangle. That's basically the sine of, you're eliminating h, which is right here, or depending which way which angle you're going from, it eliminates the need to find h. So say for instance this side is 10 and this side is 12 or something like this, and you know that this angle is 40 degrees, okay? All you have to do to find the area of this triangle, is this times the sine of this divided by 2. And the angle always has to be included between the two sides. So AB sine C or BC sine A, okay? So that angle has to be in between. So this angle is in between those two sides. So I'm going to find the area. That's area. So that should say area, not angle A. The area of the triangle, okay, in this case is equal to 10 times 12 times the sine of 40 divided by 2. Okay? So I'm going to plug that. I could simplify this in a little bit. What's 10 times 12? Divided by 2. 60 sine 40. So I can plug in 60 sine 40 into my calculator. 60 sine 40. Make sure you're in degree mode, by the way. And then you hit enter. And that area of this triangle, the area is about equal to 38.56, whatever those units are. Okay? Square units. Whatever they happen to be, centimeters, inches. Oh, 25.57, right, Mia?
But yeah,
57.
we have to do one of those, it's just what
Yeah, whatever two sides and the angle between you have, okay? Now in your homework, just one last thing I just want to show you, okay? In your homework, you have a picture that looks kind of like, looks like this. You have this random quadrilateral, okay? And all you're given is that this side is like 100 degrees, and this angle is 98 degrees.
78.
I'm not doing your homework for you, okay? And this is 10, and this is 15, and this is, 9, and this is 14. And they say, find the area of this quadrilateral. Using what I just learned, how could I find the area?
Divide it into two triangles.
Very good, Annie. See, what I could do is I could cut this triangle in half, or this quadrilateral in half, and then I could use that formula. This times this is the sine of this divided by 2. This times this times sine of this divided by 2. Add them together, and I have the area of the quadrilateral. Get it? Okay. That's it. Okay, your homework is page. What page is it? 657? 657? Page 657. 1 through 11. Thank heaven. All show work.
Yeah.
Show work. Okay, and remember, you heard it right here on Mr. Leader's famous math channel. Until next time.
I never got my folder.
Why are you taking